Hello everyone, I'm Francis Montella with ID 21060700073. Will present about preparation and characterization of ketosane monomalonate glycolaldehyde composite membrane (GSNGGA) and its application in fuel cell. Fuel cell is a series of electrode catalyst and polymer membrane that has the ability to produce electrical energy with relatively high efficiency through electrochemical oxidation reaction. In its development, the fuel cell used chemical as fuel, one of which is methanol, which is called direct methanol fuel cell or DMFG. Fuel cell component of DMFG consists of several components, namely the cathode, anode, membrane, electrolyte, and circuit connecting the anode and cathode. An important component that plays a role in ion transport is the membrane. Many polymer membranes they are commercially available that can be applied to DMFG, one of which is Nafion. But its proton conductivity is poor if it operates at temperature above 80 degrees Celsius, also causes positioning of the cathode. So develop a natural polymer membrane, namely ketosane, which is abundant and easy to synthesize. The first composition of this membrane is ketosane. Ketosane comes from snail cell and used as a polymer matrix. The choice of ketosane as polymer matrix is due to some of its medical properties, such as being hydrophilic, a good conductor in acidic solution, and can form a strong film or membrane. The ability to form a strong membrane is because ketosane has a long and strong polymer structure and can form hydrogen bonds between ketosane molecules. However, ketosane has low thermal stability. To overcome this, it is necessary to add momeronate as an organic filler. Momeronate is used because it has tetrahedral silica structure, and in the middle there is an aluminum layer that coordinates with 6 hydrogen and hydroxyl ion molecules in an octahedral manner to form a type of hydrate aluminum silicate. This structure provides good thermal stability and allow it to withstand high temperatures. In order for the bond between ketosane as a matrix and momeronate as a filler to have a good performance as a membrane, a compound is needed that function as a crosslinker, namely glyceraldehyde. Glyceraldehyde was chosen as crosslinker because it can improve the mechanical property of ketosane so that the stability of the membrane structure increases both thermally and physically. So, from these three elements, a membrane can be made which is referred to as a GSMNGGA momeronate membrane. For the first manufacturing process is the preparation of snail cell powder. The snail cell was with hot water and then dry in an oven at 105 degrees Celsius overnight. After that, the cell was crushed and sieved with 100 mesh sieve so that snail cell powder was obtained. The next process was deproteination. 105 recovered grams of snail cell powder was added with 1.5 sodium hydroxide, 3.5%. Then mix at 55 degrees Celsius at 400 rpm for 2 hours. Then separate the filtrate and precipitate. The precipitate is then washed with diesel water until the pH is neutral and oven at 105 degrees Celsius for 4 hours. 100 grams of snail cell powder was added to 150 ml of 1 molecular hydroxylic acid and mixed at 400 rpm for 30 minutes. Then, the filter and precipitate were separated. The precipitate was then washed with distilled water and oven at 105 degrees Celsius for 4 hours. Next is the acetylation of ketone into ketosane. 50 grams of ketone is added to 500 ml of sodium hydroxide 3.5%, heat at 120 degrees Celsius for 4 hours. Then separate the precipitate and then wash with distilled water until the pH is neutral and oven at 105 degrees Celsius for 4 hours. The next process is membrane synthesis. 2 grams of ketosane would dissolve with 75 ml of 2% acetic acid. 5 ml of 0.15% glyceraldehyde would dissolve with 45 ml of 2% acetic acid. 0.2 grams of momeronate would dissolve with 25 liters of 2% acetic acid. After that, the three ingredients were mixed using a magnetic stirrer for 30 minutes at temperature of 80 degrees Celsius. Then, pour in the plastic disc and neutralize with sodium hydroxide. And then, rinse with water until the pH is neutral so that GSMGGA membrane is obtained. The first characterization technique is Fourier transfer infrared or FTIR spectroscopy. By analyzing the FTIR, the spectrum of the membrane research can identify the presence of functional group such as amine group from chitosan, carbonyl group from glutaldehyde, and silanol group from mormolylonide. So, it can be seen that GSMGG membrane contains chitosan molecule bound with glutaldehyde and filled by mormolylonide. With this structure, the GSMGGA membrane has good membrane properties such as good proton conductivity, high thermal stability, and great mechanical strength. The second characteristic technique is methanol absorption. Find methanol concentration and find the best methanol concentration is 6 molar because it produces the small R's absorption. Application of the membrane is the direct methanol fuel cell. The anode plays a role produce proton from the oxidation of methanol, then by the membrane is flowed to the cathode. At the cathode, a reduction reaction occurs by oxygen. From the two cathodes produce a charge difference whose effect is that electrons will flow from the anode to the cathode. Cathode of the outer circuit that connects the two electrodes. Between the cathode and anode there is a membrane. This membrane is a selectively permeable layer through which proton and hydroxyl ions pass and must withstand the flow of fuel. So that is about my presentation. Thank you for watching. See you next time. Bye bye.